Hi, Nick Collier here. It's early March 2011. This series is called Jewelry Tricks. This segment, Chevy bumpers. So I thought about these segments last night, and these are way too thick. So I think what I'm going to go ahead and do is just roll them down a little bit thinner, and we'll end up with more segment and a lot more ability to create design with it. Okay, another little romp with the rolling mill. We'll go ahead and take these down a little bit more, just because they feel too thick. Okay, that's one step. And remember, we have 3 steps, and then we got to anneal everything again. There's number 2. There's the 3rd step. And you can see it strips these out about another ½ inch. Okay, time to take it over and anneal it. Okay, at this point, I think it's good to pick the kind of stone that I want to use. And I'm really attracted to that green tourmaline down there. It's a elongated stone, and it could fit underneath the Chevy bumper approach fairly well. It's got some good color to it, although not at that angle. There's the color. So that would be a good choice. And the other choice I'm looking at as a possibility is the sugilite. And in this light, the sugilite looks very blue. But in reality, it's a dark purple color, almost as purple as the ametrine. But the sugilite or the tourmaline seem to be the choice. Okay, the next step with these little segments is to square up one edge, a long edge, so that we can have a place to set it on the table, and they're all pretty even, and then we can measure from there, go to the top. So in order to do that, hey, we put it on the grinder. A little bit of water, and just take the edge down. You can see it's starting to clean up that edge nicely. Okay, there we go. Our edges are all cleaned up, and you can see this one side is nice and straight and even, and the other side's kind of cut up, and the lines aren't that straight. So we'll use this side to work from, and we'll create our lines with that. So once again, we're going to want the wire to fit through each one of these segments. So we're going to drill a hole in the segment, and so we want to measure the wire, and then find a drill bit that fits the wire. And this one is about 3/1000ths bigger, which is about the size of a human hair. So that's just about right. We'll take this over to the drill press and drill out each hole. When the drill press is running, and you'll see that the drill will go down into the piece. Well, for one, if we back up a little bit, we'll see that I've got a paper towel underneath the piece of wood, and that's going to collect all of the extra little pieces of gold, because we want to save every little iota of gold, seeing as how it's $1,400 an ounce these days. As we're drilling, I don't want to take the chance of the piece getting away from me, and if it's spinning at a pretty high speed with the drill bit and gets caught in the bit, it'll pretty much cut up my hands. So I'm going to use these little pliers to kind of hold on to things. Now the reason why I'm kind of going in real slow is because I don't want those chips to fly off onto the floor. If I cut them just a little bit at a time, they'll stay pretty close to the center of the drill bit. And there you go, all 5 holes are drilled. Let's get that 5th one up here. And you can see all of the little scraps that are laying around on the paper and on the piece of wood. Now, in any other metal, that wouldn't really count much, but I'll bet you there's about $30 or $40 worth of gold there. Just for yucks, I took that little bundle of scrap gold that we got off the drill press and weighed it. And it turns out to weigh out at just a little under a half a gram. And at $1,400 an ounce, that's about 20 bucks worth of gold. So I was about right. Each one of these little segments, when I drill the hole through it, has a little lip on the back side of the drill. So I'm going to come in with a burr, and you can see the burr's got about a 45-degree angle on it, and go ahead and drop it in that hole and drill the chamfer or a bevel out of that. Now that's going to be for two reasons. One is it's going to clean it up and make it look nicer, and the other is it's going to give me a little bit of room for the solder when I solder all these together. Of course, you can see that it doesn't like to just sit there. So that kind of spread it out a little bit, break away the excess solder, and you can see we've got a little edge there. Okay, a number of these are a little bit warped, and you know, we got that from the rolling it through the rolling mill and from cutting it. So we've got it on a flat surface here, and that's gonna give us the flatness that we want, and then we'll just take a hammer and tap it until we get the there we go, till we get it to flatten out a little bit. I always like to flip it over. Oh, notice here it's still not quite flat, so we'll flip it back and that did it. At this point, we can go ahead and put the wire inside of the holes. Get them to line up a little bit. And we've got everything kind of in place there, but of course there's no gap. We're going to remedy that. Now, over the years, I've kind of gathered up a copper tray of little spacers of all different sizes, but I like to have the spacers all exactly the same. So what I typically do is, and that's why there's so many little dinky pieces in here, what I'll typically do is take a bigger piece like this and roll it out, because when I get one piece rolled out, I can cut segments out of it and they're all the same thickness. And the same thickness is very important in this next step. So we're going to run this through the rolling mill and see what happens. Running it through the rolling mill, one little pull at a time. And it's going to get longer and longer and longer. And the cool thing about copper is I don't have to heat treat it or anneal it, because it's very soft material and it will just hold up to that, no sweat. Longer, continues to get longer. I'm kind of putting it through in different directions too, to give it to change the shape a little bit. You can see it's getting longer and longer. Well, it is splitting a little bit, so why don't we go ahead and anneal it real quick. Like this copper may have some alloys in it. This was just a scrap piece, so I didn't know exactly what it had. See the cracks in the edge there? And copper probably does have a bit of an alloy in it, so it tends to crack up. And if I just kept going with it, the thing would just turn to a whole bunch of little pieces. So now it's annealed. We'll run back through. Yeah, very good. So we're going to drop this in the shear. Go ahead and cut a bunch of little pieces off of it, and really this is random, so it doesn't really matter which direction I'm cutting. So I'm just going to cut 4 or 5 small pieces and pull those out of my scrap tray. And you can see that we've got a few pieces here. So now we're going to do this one more time. We're going to cut these pieces into little small segments, the opposite direction. So we've got 4 segments out of that. We've got 3 more out of that. So that's 7. And there's 8. And there's 9. And let's do 10. Okay, so we've got our 5 pieces here. Now we're going to want to separate them just a little bit. And what we're trying to do is create notice that this is the side that's all flattened and that we flatten down a little bit. So we're going to flip those over so they sit on the table nice and evenly, even though the holes could have thrown them off a little bit. So now we're going to just spread these apart just a tad. And you can see that the copper is going to fit right in between each one of these. And I need to get a pair of tweezers because my hands are way too big to deal with this stuff. Second one. Third one. Fourth one. There we go. Now I like to stand them up lengthways here. And notice how I've got them all a long ways away from this center post, because this center post we're going to weld. And we don't want the solder even coming close to the copper. Now the copper, when it heats up, it gets a fire scale on it, and so it doesn't allow the solder to come into the copper and attach to it, although I've had that happen on very few occasions. But mostly what happens is the solder flows in towards the little shaft and then and doesn't go and touch anything else. So we can take these small segments back out later on. All right, there we go. Now we come in with with 2 little C-clamps. We're going to close this up a little bit. There we go. That looks beautiful. Come in with a C-clamp, close the C-clamp up onto it. And you can see that is just going to hold everything in place nicely. Pull these couple of little coppers in a little closer on, just to get good support in between them. And put the second C-clamp on. A little awkward there. Now, everything is just snugged down. So what I'm going to do is go ahead and adjust all of these segments so that they're sitting nice and evenly. And also I want to make sure that the center shaft is nice and square, and it is. And now I'll go ahead and take everything down just another little notch. We're not going to really cramp down on it. Just pull it down so it's good and snug. So when I pick it up, it's a single unit, and it just stays right in place and isn't going to go anywhere. Now let's take it over the welding table.